Welcome everybody to this India Next webinar number 5 sponsored by Ultratech. It's indeed a great pleasure to join you, and I'm Kshemendra Nath from Resilient Energy India Private Limited. Before we start the webinar, some practicalities. Just wanted to let all of you know that you are muted. There is a handout of this presentation being available which you can download. And after the seminar, there will be a webinar survey, which I would request all of you to take it. After the end of this presentation, there will be questions which you can ask for. And I will try to answer how much I can. And if I'm not able to answer all the questions, then I can revert back to you with on my email. The subject today, what we are going to speak on, is ready-mix concrete in construction, common issues and solutions. So look at the outline. I'm going to talk to you about first a brief introduction about the RMC industry. Then I will get into the main subject today, which is the common issues associated with the RMC usage in construction. And I will wind up this with the future challenges and what we see will be most of us sustainable solutions, not just for the ready-mix industry, but for the construction industry at large. To start with the ready-mix industry, the first ready-mix plant in India, the commercial ready-mix plant in India, started in 1990 in Pune by one Mr. Kelkar. Unfortunately, this enterprise was not a commercial success. It was in 1994 that, for all practical purposes, the ready-mix industry kick-started in Mumbai. Unitech Prefab and ACC had set up two different units in Mumbai in 1994. Soon after, RMC Group PLC, at that point in time, was the biggest and the largest ready-mix producer in the world, entered India and set up their office in Mumbai. So at the same time, Fletcher Challenge from New Zealand, which is a building materials major, also set up the operations in Bangalore. So this you could understand, these were the early days of the liberalization, and for the multinationals and the world majors to see Indian ready-mix concrete as a potential market, it was a very big, very important step at that point of time. Another major milestone was the second revision of the Indian standards for ready-mix concrete in 2003. This was a more comprehensive document which had come up and covered the ready-mix industries and the guidelines for use of ready-mix concrete in India. Maybe many of you may be surprised that this code first came up in 1968 and the first revision came out in 1976, 14 years before even the first plant started in India. We always believed, I've been associated with this industry from 1994 as heading Unitech Prefab's operations in Mumbai. I always believed that RMC industry will act as a catalyst in modernizing Indian construction. If you were to look about the construction industry in India before 1990s or 1995 or mid-1995, you could hardly find a tower crane in any of the construction sites. But today, if you look, the skylines of Mumbai or Bangalore or Delhi is dotted with a lot of tower cranes. M45 was the highest, strongest grade concrete made in those days. But today you have more than 1 million cubic meters of high strength concrete, M60 and even M80 and M95 that is being used in this country today. You have expresscrete, you have colored and textured concrete, self-compacting concrete. So in a way, ready-mix has proved as a catalyst to change and modernize the Indian construction industry and has given a lot of support to technological development. If you look at the industry today, there are 1,000 commercial ready-mix plants. I'm not talking about the captive plant. 1,000 ready-mix plants are available in 95 towns and cities. The industry turnover is around $2.8 to $3 billion. 50 million cubic meter plus concrete is being produced annually in the country today through ready-mix concrete. And even this is hardly around 15 to 17% of the total concrete that is being produced. So there is quite a lot of growth area possible for this industry going forward. And by the nature of the business, we also find that the large players, 5 to 6 large players who are with a pan-India presence is operating in this space. But then looking at the nature of the product, it's not surprising that this industry is dominated by local players, because you take local raw materials, you interact with a local building fraternity, and you are also taking this product doesn't have a shelf life of more than three hours. So this is a snapshot of what the industry, how it has grown in. And I will now go into the major common issues which the customers or the users of ready mix often encounter. I've been with this industry, I said, for the first 10 years, but then I've moved out of this industry and I came back in a year back. I found that most of the common issues which I faced in those 10 years are the same even now, even after the industry has progressed so much. Inconsistent raw material has always been an issue. Aggregates, good quality aggregates with bulk volumes is still a challenge. Although cement industry has progressed so well and 300 million tons of cement is available in the country today, in search of the best price and commercial deals, the RMC supplier is forced to constantly change the source of cement, which is a major impact on the quality. Fly ash, which is a key supplementary cementitious material, is still a traded commodity with minimal quality standards. While a lot of focus is on cement and aggregates and admixtures and fly ash, what people tend to overlook is the potable water quality. Potable water is recommended for making concrete, but the fact of the matter is most of the ready-mix concrete industry don't have access to industrial water supply or the municipal water supply, and they have to actually fall back on the water suppliers or drilling their own bore well. The quality of the water which may come out of the borewell need to be actually ascertained, because there could be the chloride limits or the sulfate limits could be beyond the permissible limits in some parts of the country at least. So this is some area where people need to focus on. So how do you deal with these situations? When you look at the source of aggregate, single source is an ideal situation, but we all know we don't live in an ideal world. So if multiple sources have to be used, then make sure that the aggregates are what we call as a demonstrably similar category. When I say demonstrably similar, we are looking at the key properties of the aggregates, which actually allow the variability or its impact on the variability of concrete to be even lower. So if you need to have for multiple sources, I would advise go for 2 or maximum 3 sources. Ensure that it is of the same petrological type. You have the right, the dry loose bulk density is within plus minus 75 kg per meter cube tolerances. The apparent particle density is within plus minus 0.04. And the average gradings is within plus minus 10% in the mid-band sieves. Apart from this, I would also say that make sure that you don't have high degree of variability in the 75 micron passing in your crushed sandstone, which is used as a fine aggregate. If your business demands that you need to go for more than one source of cement, please always use only one cement in a silo. Don't mix the cement. And if you need to move in, I would advise that please make sure that you shortlist 2 or 3 cement of similar performance. When I say similar performance, in strength, in workability retention, in setting, and in strength gain, so that you understand that even when you have to switch over, you are ready and there are no surprises. From a document control and the control from a technical perspective, maintain a documentation of the master list. A master list will say that in a particular plant, which are the sources of raw material that have been approved from the technical point of view. And then there should be an approved material list at the plant, which is a guideline for the plant officer for inwarding the material. So at any point of time, the inwarding material should always be a part of the approved material list. And when you do the incoming material acceptance, there should be a clear written down procedure to deal with the rejections. And Monitor the frequency and give a feedback to the aggregate supplier so that you can constantly improve the incoming material quality through dialogues, discussions, and communication. The next part of the common issues, which is of big problem, is the concrete tube strings. Quite often, you get disputes between the concrete supplier and the customer, saying that there's a big mismatch between the concrete cube results. Before we get into the cube results thing, one of the most important factors to keep in mind is that you are sampling and testing the product right, and the test results, what you get is a true reflection of the concrete that has been supplied. The Indian Standards 4926 very clearly tells you how to do the right method of sampling. You should let go the first 3.3 cubic meters of sample when of the concrete which comes out of the truck mixer when you do the sampling. And you should not take the sample from the last 1 cubic meter of the truck mixer. So you have to take in 4 increments whatever anything between the first 0.3 and the last 1 cubic meter of concrete, remix it properly, and then cast the cubes with that. It's also important to know the direction in which you actually do the sampling. What you see on the left in the middle is the right sampling with the scoop, which is parallel, which is perpendicular to the flow of the concrete. Using the right cube molds, using the right curing, using the right testing, the test machines are all important to ensure that you get the results which are reflecting the quality of concrete. Otherwise, this dispute is not going to, you'll be barking up the wrong tree, because in the first place, the result itself is not proper. Now, if you don't sample or test right, what is the kind of implications? Now, this is taken out of the Manual of Ready-Mix Concrete by Joe Javer and Anderson. And a sampling error tells you that you could get a result which is plus minus 10% of the true average cube results of the batch of concrete. Failure to remix the sample can give you a minus 15% negative results. There are other issues like your cube mold, your lack of mold oil, distorted cube mold. If the cube molds are not perpendicular in each other in the face, you have a problem there. Incomplete compaction of the concrete can give you issues. Curing temperature outside the permitted range. Your permitted range is 27 plus minus 2 degrees centigrade. If you cure it higher or lower, you will have different kind of strengths. The lower the temperature, you will get lower the strength. Higher the temperature, you might get up with increased strength. One practical issue which is observed everywhere is a lack of moist curing. Your standard talks about using the concrete. The cubes have to be put in water, cured under moist conditions for 28 days. If you do not cure the concrete in the first 3 or 4 days and is left outside and then you cure it, it will impact the strength. If you don't continuously keep moist curing, you will have a problem with the reflection, and that is not reflecting the true quality of the concrete that is supplied. Faulty cube location, operator faults, and even one of the major issue is your faulty test machines. Your test machine should be first capable of testing the concrete in place. If you make an M60 grade concrete and you have a 1000 kilonewton capacity machine, then it is not going to test. It is not going to be useful. So these factors have got to be eliminated before you actually come to the result that come into a dispute situation. Now, having said this, if you still have a problem, how do you actually address that? Right here, what you see on the screen are some pictures of different non-destructive tests available. On the top right-hand corner, you have the ultrasonic pulse velocity test. On the left bottom, you have the Schmidt hammer or the rebound hammer. You have the concrete pull-out test equipment next to it and the core test. So these are different non-destructive tests which is available to the user to find out what if there is a dispute, whether the concrete in question is good or can be or needs further strengthening. But before you go that, there should be a discussion. A detailed program has got to be chalked out, And the reasons for investigation has got to be clear in the minds of the people concerned. What do you really want to get out of the investigation? Do you need to estimate the in situ strength of concrete? Or do you feel that the concrete which has been supplied is only problematic in some areas, but the rest of the areas are okay? So is it a comparison what you need? Or do you need the investigation at the surface, near the surface, or do you need the investigation to be made in depth? Now, depending upon what you define, then you can choose your type of non-destructive test. And this particular slide compares the relative merits and limitations of various tests. We have taken 5 different tests. If you need the region tested, depending upon the region tested, if you need an in-depth testing required, then core and ultrasonic pulse velocity are the tests you need to go. A rebound hammer will not help you there. There are various standards available. The British standards is what I have quoted over here. British standards EN 12504. And the more the stars, the better the impact is. So if I look at the accuracy of strength estimated is what you need to find out, then core is what you need to actually look for, not the Schmidt hammer. But if you are looking for a quick and easy test to estimate whether it is need to be further investigated, then a rebound hammer may work because it will give you a quick speed of test and the ease of test is better, the economy of the test is better, and it does minimum damage to the structure. So this, I'm not going too much into detail, but what I need to tell you is that depending upon what is the issue you define, look into the issue, look into the various possible options available, and then take your decision. To avoid the situation, the ready-mix concrete plants should exercise good quality control. And quality control in ready-mix is broadly classified into 3 areas. The first one is the forward control, or the controls you put in place even before you batch the concrete. And this includes, we talked about the monitoring the material a few minutes ago. I'll not go into it. The material storage, you need to store your cement in the proper silos. You need to have the aggregates on a concrete base. You need to have the partition bins properly in place so that you don't have the spilling of aggregates. Now, these are the fundamental things you need to have in your concrete to make sure, in your plant, to make sure that your quality control is in place. Plant maintenance is another key issue. This plant maintenance will involve a lot of daily checks which the batcher needs to do before he starts batching. There are a list of plant maintenance schedule based on what the OEM tells you, which needs to be conducted at a particular frequency. Then you need to also look at the calibration, which is as per the defined frequency you need to do for the weighing, for the cement weigh hopper, for the water weigh hopper, for the admixtures, for the aggregates. So all this needs to be done to make sure that your concrete is in chip shape. Plant mixers, truck mixers, these are all have got to be inspected and made sure that, you know, the forward from a forward control perspective, these are all being maintained, well maintained. When immediate control is when you actually do the controls at the time of batching. So the batcher should always visually inspect the concrete before it goes. For a trained batcher's eyes, he can make out whether the concrete is cohesive or the concrete has got lower slump or a higher slump. There are ammeters which are installed inside the mixers, which through the resistance of concrete can measure or can be correlated to the slump. Regular monitoring of the moisture content is another key area. There is a practice where for dust suppression, water is sprayed on the fine aggregates. It's fine, but it also means that if you don't remix the sand properly, you might get a higher water moisture content of 10% in one part of your sand bin, and the other part of your sand may be relatively dry with 2 or 3%. So this can play havoc in your in your slump and in your workability. The batcher should also be able to adjust the mixes to change the materials and concrete at that point of time, because you're already batching. So he should be trained and should be able to take that decision, although that is only a temporary one. And when the truck mixer turns up the site, there should be an inspection done for measuring the slump. The third control is the retrospective control. We talked about the sampling of concrete. weighbridge checks I'll come to later. Stock control is another important check, because when you do a stock control of your material every fortnight or at least once in a month, then you will be able to detect whether there is any mismatch or the in the calibration or in the weighing of your materials. And using statistical quality control analysis and finding the performance of the concrete is a very important tool. Unfortunately, many of the ready-mix concrete suppliers do not use this as a regular practice. I will give you a very quick example how the British ready-mix concrete industry operates. They operate from a cement content to strength relationship. They define this through a series of trials based on different cement contents within a particular range. Then, based on the polynomial equation, they will be able to know this equation will tell what is the equivalent cement content, the strength for a particular cement content. For example, at a 400 cement content, you know that this concrete should be giving you 47 newtons. So at every cement content, you know what is the equivalent strength this particular group of materials will give you with that particular cement. This is used as a baseline for monitoring the performance of concrete at site. So when you get your cube results, the cube result is first compared against the base strength, what it's supposed to give, and the sum of the deviation is monitored. The sum of the deviation, which is the cumulative sum of the deviation, is the QSUM analysis by which you pick up the trend. Once you pick up the trend, here you have the QSUM mean, which tells you whether the strength is going down or going up. Based on this, you need to actually adjust your cement content. Now, this is also using a correlation where you predict from a 7-day to 28-day what is the strength required, and before you actually expose yourself to 28 days of production, you will be able to take quicker decision. This is actually not only monitoring the quality. My experience with using QSUM in India is that you save around 30 to 40 kilos of cement per cubic meter because you are able to exactly monitor the performance and put things back into place. The third issue which I would like to talk to you about is the cracking of concrete. Before we go into the cracking of concrete, I would like to tell you that let us look at the construction ecosystem. If a building is in question is got to be built, there is the client who comes with the money. They have got the architects, the specifiers, and the project management consultants who are responsible for the whole quality and the execution of this. Then you have a contractor who actually executes this building. So the ready-mix supplier's role in this whole context is limited to getting the right material, doing the right mix design, transporting it in the right quality, and then pumping it in place. Therefore, my submission here is that while cracking is an issue, some part could be related to the ready-mix suppliers has a better control on some part of the equation. Mostly it is got to do with the construction practices. One of the most common, there are different types of cracks which can happen in non-structural cracks in the structure. This is a slide which I borrowed from the Concrete Society's technical report number 22 on the non-structural cracking. If you look before hardening, there is a plastic cracks, plastic shrinkage, and plastic settlement. Thermal cracks induced due to the thermal gradient. Then there's crazing and drying shrinkage, which are the normal cracks which you observe in ready-mix. So for the sake of this particular webinar, I will restrict myself to 3 different types of cracks, which are the most common type of cracks which is observed. Plastic shrinkage cracks is the most common cracks which is encountered, and it looks like this, what you can see on the screen. These are random cracks, and this is now the way you can identify this crack is that this seldom goes to the edge. Unlike what many of you think, a plastic shrinkage crack goes through and through. So if you pour curing water at the top, you can see the water leaking at the bottom of the slab. Structurally, they are harmless, but it can create quite a lot of durability issues because you are allowing a crack to happen in your system, which is not a desired thing. Why does this happen? This happens because of the loss of moisture in the early age of the concrete. When I say early age, when the concrete has started setting, but the concrete is not hard enough to take the load. So when you lose moisture from the surface capillary tension is created on the surface of the concrete, and the concrete per se is not strong enough to take or withstand those cracks, and then it cracks. So the only way you can prevent this, or the best way you can prevent this, is to start early curing. And when you do early curing, how early is early? You need to make sure that when the concrete starts, the sheen on the concrete is off and it starts looking a little bit dull. That means the moisture is, you started losing moisture from the surface. That is when you need to start the sprinkling of water, or cover with a plastic cover, so that you prevent the moisture loss. There is a very good graph which is again given in the Concrete Society technical report, which tells you when you need to be careful about, or what precautions you need to take. It's a combination of air temperature, which you can see over here, and this is the relative humidity. So lesser the relative humidity, more is your evaporation loss. So suppose you take, this is in Fahrenheit, so you need to convert into centigrade if you're comfortable with the centigrade, which we are all. And from this, you find out what is the placing temperature of concrete. From there, you come down to this particular graph, which is your wind speed. And then when you plot it back to your y-axis, you will get the rate of evaporation. So if your rate of evaporation is less than 0.5 kg per meter square per hour, then you are okay. If it is exceeding 0.5 kg per meter cube per hour, meter square per hour, then you need to take precautions. The second one is the plastic settlement cracks. Now, this is different from plastic shrinkage cracks. This happens when the concrete settles immediately after vibration, and the bleed water comes to the surface, and the cement and aggregate settle down. And there is a restraint to this settlement. When I say restraint, it could be in the form of reinforcement, or it could be a change of section. And immediately above that, you will find the cracks to develop. This can be easily prevented by, one, a good cohesive mix. Secondly, revibrating the concrete before the concrete is set, because you can disturb the cracking pattern, and then you can overcome the plastic settlement crack. Another crack which is normally observed in deep sections or foundations are the thermal cracks or thermal contraction cracks. This is the typical way in which the concrete cracks. This happens in thick sections, where the differential in temperature and the temperature gradient actually is the cause of this problem. If you can imagine a 2-meter thick raft and you're pouring all that together, then after the concrete is over, the temperature at the core is definitely much more higher than the temperature on the surface, because the temperature at the surface, the temperature can evaporate, can dissipate into the atmosphere very quickly, and then the temperature at the core is hot. If your temperature differential between the core and the surface is more than 25 degrees, of course, depending upon the aggregate properties, then there is a vulnerability for the concrete to crack. The major components which are the contributing factors here are the cement type. If you use only OPC, then you have a higher heat of hydration. So if you use 50% slag or 60% slag, your heat of hydration and thereby the temperature developed at the core also can be reduced. The cement content. Now this may contradict with your minimum cement content. So this is a prudence you need to exercise. If you need a minimum cement content, then try to make the concrete within that particular cementitious content. Don't specify very high cement content, because from one end you are creating another problem. Initial placing temperature of concrete, try to place the concrete, especially in raft, maybe around say 25 degrees centigrade, or even better if you can go below 20 degrees centigrade if the thickness and the section is too large. So there are ways in which you can overcome, but again, this is a combination of specifications, the material used, and communication with the specifier, the user, and the ready mix player is extremely important to avoid these kind of issues. So in a nutshell, I would say that cracks are undesirable, but then you need to also understand that this is not just the responsibility of one player in the whole gamut of construction. I'm being too quick. I understand this, but I have tried to pack in as much as information as possible in this 50 minutes. So you have to bear with me for being too quick on this. Another issue which perennially happens is how do we allow reworking of concrete at site? Now, this is the harsh reality. This is there for us to see. The traffic in any city is completely unpredictable. Normally, a ready-mix supplier designs for the retention of workability based on how much time it takes to transport the concrete and how much time it takes for placing the concrete. And then they put a margin on top of it. But sometimes what happens is that there may be a unpredictable traffic which delays the arrival of truck mixers. At the site may not be prepared, and there's a delay in actually starting the concrete, or even the placing may have hampered. Another reason could be the change in raw material source. If you change the cement type or cement suddenly, then you might land up with too much of fines or C3A content or C3A content or C3S content. Anything can actually have developed incompatibility with the admixtures. Or you have high fines in the sand also can create this. So any change in the raw material source will create problems over here. And incompatibility of the admixture and cement also is a large contributing factor here. What does the code say? Redosing of the admixture is not harmful, provided the admixture you're going to redose is still within the maximum permissible limits prescribed by the admixture supplier. And more importantly, the concurrence of the site personnel needs to be taken before you actually redose the admixture. It's always preferable to use super plasticizer than a retarding plasticizer, which can affect in terms of delays in setting. Another issue is that can we allow water to be added? Now, IS 4926 says that if there is a requirement for the to increase the specified workability before discharge, water can be added provided there's a specific request from the RMC supplier and it is signed in by the purchaser. So the agreement, so the crux of the matter here is dialogue, discussion, understanding, trust, and then taking a decision. You need to take a decision because you cannot afford to throw away the concrete, 5 cubic meters of concrete if that can be used. But at the same time, if the concrete is not in a position to be used, it is might as well taken away then rather than putting into the structure. But then if anything can be done to that concrete to save the concrete, it has to be done, provided your structure is not harmed. So this is something which needs to be taken at the site level. Then you have the problem of short measure, which is again one of the very common problems, where you see that we had ordered 45 cubic meters of concrete, but I had to consume 47 cubic meters of concrete. 2 cubic meters of concrete was in excess. Now, why does this happen? This can happen due to many reasons. It can happen at the batching plant because of batching errors. Your computer might be showing that this much amount of concrete has actually been batched, materials have been batched in the same proportion as you have designed it, but that could be a slippage. There could be a built-up of material inside the way hopper, which is actually always giving you erroneous readings. These are the issues which can happen. The change in source of materials. Suddenly you have taken material which is not in the approved material list, and then you have got higher specific gravity or a lower specific gravity. You have a problem because you normally batch in weights and sell in volume. So specific gravity is a key component in determining your measure. It could be wastage or spillage at site, but most commonly what is being observed is that it could be a simple case of miscalculation of the volume. Or if you have a foundation which is over excavated, or if you have a movement or deflection of the formwork, this can also contribute to a higher volume of concrete or a lower volume of concrete that is being consumed. For example, if the formwork of a 150 millimeter thick slab is deflected by 5 millimeters, at the center you'll have a 3% increase in concrete. The way to check this is that you check for the yield of the concrete. In your design mix, the RMC producer will tell you that this is the total amount of batch weights, and that batch weight should give you what 1 cubic meter of concrete is designed for. IS 4926 is very clear. The supply and invoicing will be based on cubic meters, on volume only. So there is no way that the specifying body says that you should go and measure the structure in at the site and then certify. So it doesn't work like that. There should be a trust. There should be quality inspected into the RMC producers' operations. And when you check for yield, the one way to do it is to take a standard container of a known volume, maybe a 10 liter sample container, take the sample of concrete, fully compact it, find the weight, then you find what is the yield. The weight by the known volume will give you the specific or the yield of the concrete. So by this way, you can actually find out whether there is a difference in what is the design mix is telling you, and whether there is a problem with the batch weights, whether there's a problem with the actual deflection of the material or not. Another alternative is to use weighbridge. You can drive the truck mixer onto the weighbridge, check the weight of the concrete, empty it, and then take the weight again, so you know exactly how much amount of volume has got, weight has gone, and for the as per the delivery challan, what's the volume. So you can actually check this, repeat this to ensure that you get the right yield. So this is one way of actually checking the yield and trying to find a resolution to this dispute of short measure. Then we will come to what we call as retrograde specification. These are regressive specifications which are still in place even after 24 years of ready mix being available. Next year in 2019, if we take 1994 as the commercial ready mix being practically available in this country, we will be celebrating the 25th year of ready mix in India. And still, you will be surprised to see quite a lot of specifications which are retrograde in nature. Let's examine some of these. You walk into any ready-mix plant, especially in the metros. It's not in tier 1 or tier 2 cities. It's in the metros the major problem happens. There is a high ratio of prescribed mixes relative to performance-based specification. When the whole world is moving towards performance-based specification, here we have the specifiers writing down what is the prescription in which you have to batch the concrete. Now, you can very well think there is a ready-mix concrete operator whose core competence is been making concrete. He understands the behavior of the concrete. He understands the material better. He understands the traffic better. And then he is being told to mix a particular brand of cement in a particular proportion with this particular sand and that particular water and a third degree and another set of admixtures. From a ready-mix producer's point of view, think how many cement can he store in his plant? How many admixtures can he store in his plant? You need to give that flexibility, and on the contrary, you should be demanding on the ready-mix supplier to deliver quality. You should be having that trust that you inspect his quality standards and ask him to give performance. I need this particular strength. I am accepting this particular variation. I want this particular chloride penetration value. I'll specify this durability. End of story. Don't go into telling him what to do, because a prescribed mix, you as a supplier, you as a user or a buyer is taking the monkey off the shoulder of the ready-mix supplier and putting on your own shoulders. Because as per IS 4926, you only specify the performance of the concrete is not the ready-mix producer's responsibility. He will jolly well give you the mix and then tell you, here, Mr. Customer, you have asked for this proportion, I badged it and given it to you. Very high cement contents to ring fence possible failures. Now, this is a surprising element. You're going back to the situation where you are talking about site mix concrete. I need 500 cement content in an M40 grade concrete, because whichever way I look at the concrete strength will not fail. Now, that are better means to achieve your quality rather than going into these kind of situations, because come to think of it, why should a ready-mix supplier invest his time, his training the people and energies into getting the quality right and giving you a better technical solution? Basically, by doing these kind of specifications, you are bringing them down to the level of a mixing contractor. So end of the day, you don't allow for technical excellence to come. You are not encouraging better technology to come. You are not encouraging the ready mix player to invest into better and new technology. But on the contrary, you are bringing them down to the lowest common denominator. This is not going to help the industry. There has been specification which says that I will use the concrete based on strength results from the cubes cured along with the slab casted. Now, the specifications are very clear. The concrete strength is specified for 28 days of curing and testing under standard conditions, storing, finish, period. But you cannot have a specification say that just because my slab I don't cure, I need the cube also to be cured in the same manner as the slab is being cured, and I expect you to meet the standards. It doesn't work that way. If I can draw a parallel, I can tell you, if a particular car manufacturer is giving you a car which tells that 25 kilometers per liter, then it is under standard conditions. There is a standard on which universally things are accepted. I cannot ask that I will drive this in the Mumbai traffic in the first gear and I expect you to give 25 kilometers per liter. So let's be sensible enough. Let's understand and let's work together, because only that will help us to move forward. Insisting on a high number of cubes, the ready mix is the, why do you do cubes? You're sampling the production. You're trying to find out the variation in the production. And when you do a mass concrete, IS 4926 is very clear. You are trying to find out the production variability. So for 50 cubic meters, you need one set of cubes. If you need another set is fine, but when you ask for every truck to be sampled, then it is asking too much, and it is not going to of any help. World over, nobody does this kind of sampling, and this needs to be understood, because if you need to put that resource, it can be deployed anywhere else which can serve the customer better. We talked about cracks, and we know that cracks is not the problem associated with only one section of one segment of the construction chain. So please don't insist on crack-free supplies of ready-mix concrete, because it is a problem which needs to be addressed by everybody jointly, collectively, because the concrete will crack, whether you blame it on the ready-mix player or not. It will crack if you don't take the precautions at the site. So way forward, we need to be more progressive. We need to move away from the prescribed mixes. We need to move to performance-based specifications. Make the RMC producer accountable for the quality he gives, and that should be using quality systems. Use that as a benchmark to differentiate the good ready-mix producer from the not so good ones, and put pressure on the not so good ones to uplift themselves to be a better ready-mix producer. Do not only go by price as the differentiator, because if you do that, then you are not helping good producers and good construction practice and good concreting practices to come. There are ready-mix players in this market who have got 25 years of experience. Pick their brain, get the best out of it, use their expertise and their core competence, and work with them to drive excellence. He will be able to provide you a lot of solutions, provided you give him that respect and you give him the kind of freedom to operate. And the QCI certification scheme is a very good step in benchmarking the ready-mix players. But two areas where we need to actually broaden the scope of the QCI is in the order processing and also the retrospective quality control. QCI heavily depends on the materials, on the production, and on testing. But if I can show you this chart, this is how the whole quality system operates. The most important thing over here is ignored in the QCI thing, which is the actual order review. And the communication happens from the customer to the salesperson. What he tells the salesperson is more important, and how the information is cascaded down. Now, this should be properly recorded, and this should go into the technical system for them to understand before they put the batch instructions. So this is a very, very important step which is not being covered by QCI, and I will definitely say that this has to be a part of your quality systems. The technical systems take care of the materials, purchasing, do the mix design, do the samples, and then is fed into the concrete plant as a recipe for production. The production team looks after the weighing and measuring the equipment, doing the calibration, doing the maintenance, the preventive maintenance and the stuff, so that the concrete plant is in the right shape to produce the concrete. And once you have that and you produce the concrete which goes out is sampled at the customer site. And if there is a problem with the concrete or non-conformity, either you can rework that or you can take it back to the plant, or whenever there is a non-conformity, it is recorded and put back into the system so that the system takes care of improving this. So this is the gamut of a quality system in which the whole value chain understands what is being done, right from the salesperson to the person who is making the cubes is involved in this whole system. So this should be the way forward for looking at the quality systems for ready mix. Finally, I would come down to the future challenges and sustainable solutions. I would focus more here on the management of waste in the concrete. If you look at any ready mix, the average 2 to 3% of concrete production is returned, rejected, dumped, diverted. This is the thumb rule. Now, if you can imagine 5,000 cubic meters in a day, then you can expect somewhere around 100 cubic meters of concrete in this category, which may come back to the plant because of a pump failure or the redosing of admixtures or whatever be the problem is. The fact of the matter is many plants do not have the capability to handle this issue. Just because you don't have the capability to handle the issue doesn't mean that the issue disappears. So this concrete is going somewhere. It might be dumped at the lowest or by the roadside or some areas, and this is an environmental problem. This is a problem of the whole industry. So we need to have a proper way in which you address this. Another issue is when you look at the wash water, it's discharged into the ground without any treatment in many plants. And it is so alkaline that it will actually increase the pH of your soil and stop the vegetation growth. The way in proper management of this is by using wash pits. You can have different methods to do this, but if you recycle this water, the international standards, whether it is the ASTM or the European or the British standards, they permit water to be recycled, the recycled water to be used back in concrete, provided you can establish that the difference between the concrete made with the mixed water is at least 90% of the concrete you normally batch. Then there are limits to alkalinity, sulfates, TDS, which actually make sure that you can use this as a part of 40%, 30%, or 50% of a mixing water, and you're recirculating the water back. So you are avoiding one, wastage, and second, you are actually conserving water, which is a very precious resource. Then what happens to the concrete we mentioned, which is coming out in large chunks and is dumped somewhere? Most places you find that rivers, riverbeds, or the lakes are full of concrete. You need to actually collectively find a common place where you can actually dump the concrete. After the concrete is set, you can actually crush the concrete and use as recycled aggregates. You can even use chemicals which will actually stabilize the concrete overnight and use an activator, and you can use the concrete again. Or you can use some admixtures which can actually segregate the slurry and the aggregates, and then you can actually. So we need to work out how are we going to deal with the situation rather than close our eyes. I'd like to share one of a very simple wash water facility. In this particular thing, you have it's a simple mechanism where you have three chambers of pit. In the first chamber, you have where the front end loader can go in, and then the water is filled in. The front end loader can go into, or the truck mixer can back into it and throw the water in. Over a series of wedges, the water is cascading over to the next one where the sediments are lower, and then to the next one where still better, clear water is there. And from here, you pump it into a holding hopper where it is always kept in turbulence using agitation mechanism. And this is washed. This is fed back either into the mixing water or into your cleaning of your trucks. There are other sophisticated methods. You can use a recycling, aggregate recycling unit where you have a recycling unit where the aggregates are separated. Your slurry water is again put into another tank. You can you can pump it into a filter press where the slurry is again where the sludge is separated and the clean water is taken. So depending upon what you need to do, we need to address this issue one way or the other, because going forward the environmental laws will become very strict. You need to operate within the city, and then there will be quite a lot of pressure on the ready mix industry to adapt these things. Finally, I would suggest, I'll leave a food for thought for you. Think of this: the construction industry is the largest consumer of resources. It contributes to 25 to 40% of the carbon emissions worldwide. China had used in the last 3 years more cement than what US had used in the last century. Sand and gravel is the most extracted group of materials. So you can understand, if China is one example, then you got India and the other developing countries. So what the resources are developing are depleting on one end. 40 billion tons of aggregates are consumed every year globally. At the same time, you have 4 billion tons of construction demolition waste, which is generated, which is hardly reused in countries like India. Even in Europe, you have hardly 30% of this construction demolition waste that is being utilized back. So it doesn't take an Einstein to figure out that RMC industry will be challenged to reduce the resources and use more of the industrial waste into concrete. Whether it is steel slag or copper slag or construction demolition waste, adapting and embracing this change will define the future of the concrete industry worldwide. And at this note, I will stop, and I will take questions from you, whichever, and I'll be happy to take those questions. Do you know the name of the person who have asked this question? Can you read this out? For mixed design, why we take initially grade of concrete? This is the question from Neeladri Kaur, and the question is, understood it correctly, for mixed designs, why we take initially grade of concrete, example M20 and 25. See, the grade of concrete is the first one. Yeah, the grade of concrete is specified by the user. So if I want to place an order, I say this particular grade of concrete is what I need. Then based upon the ready mix concrete supplier's ability to produce, he has to give a margin on top of it. So if it's an M25 and if he has got a standard deviation of say 5, then taking into account the acceptability failure rate of the statistical value of 1.65, he needs to go for a higher grade to add that margin onto the 25 or 20 Newton of the characteristic strength. And that is how you actually design the concrete. So at the lab, if you need an M25, the lab results should give you something like 8 Newton or 10 Newton more than that. So maybe 25 should give you 35 or 32 depending upon your control. But this is to take into account any possible variations in the production. So this is not, the target strength is not what you need to achieve in the field. In the field, the IS regulations says that acceptance is based on a non-overlapping mean of 4, which the average should be FCK, or the characteristic strength, plus 3. So these are two different things, if I've understood the question right. Is retarding of admixture allowed at the placement point of concrete by company? Is redosing of admixture allowed? Of course it is allowed. This is what I covered in that particular slide. As long as your redosing of admixture, the admixture you are adding is not exceeding the maximum permissible dosage, it can be used. For example, the admixture supplier says the maximum permissible dosage of this admixture is say 2% by weight of cement, and in the initial mix at the plant you have added 1% by weight of cement, then technically you have an opportunity or window of opportunity to use up to 1% by weight of cement at the plant. But again, you need to assess the slump available there, what you need to add there, and also be careful about what is the balance cubic meters left in the concrete, and you need to add into that. So you need to exercise, you need to be trained to handle the situation, but it can definitely be done. Whether it follows mixed design code 10262. Now, 10262 is a guideline. Now, that is not the only way to do a mixed design. So this is where a lot of people get confused. A guideline is not a specification. It is not it is only telling you that this is a way to do it. But there are different ways, and if you do mixed design by 10262, you will not be able to produce a good quality concrete from a ready mix perspective. So the ready mix player will have his own method of designing. What one should be worried about is whether it is achieving the strength, whether it is compactability, whether it is able to give you the right workability, whether all the durability factors are being honored. These are the things you need to do. How that is being designed should not be the criteria to decide, and never prescribe that all the mixed design has got to be to 10262. It's the wrong way of looking at things. Do you have the name of the persons? Okay. Okay, now there is a question from Nitin PM who's asked that does this plastic shrinkage has anything to do with the strength of the structural elements? Structurally, this doesn't affect the structure. That's what I said. But durability wise, it can create problems. This is something which has happened when the concrete is moving from a plastic stage to a hardened stage. The ability of the structure, the concrete to take the load is not compromised, but you need to deal with this because it will open up opportunities for the chlorides or sulfates or water or carbonation to happen. So from a durability perspective, it's something which need to really take care of. Then we have what is the role of cement in maintaining the retention of concrete? Ashish Dange asked this question: what is the role of cement in maintaining the retention of concrete? Obviously, I had a slide, of course, because I didn't have enough time. I had to cut it back. The cement properties are extremely crucial. If you have higher C3A content or a higher C3S content, it will affect the workability. It is not that you cannot make concrete with that, but you need to be taking these things into account. Higher alkalis can increase the water demand. Higher fineness can increase the water demand. So if you have cement particularly contributing to higher water demand, then you need to factor that into your mix designs. So cement properties will definitely affect your concrete retention. Its compatibility with admixture is another key thing to take care of. But then this is the challenge also when you move from one brand to another brand in a ready mix operations without checking your things right. So you may end up with a brand of cement which may not be compatible with the admixture you are using. So these are things which you need to do as precaution in the background and do the testing right and keep it ready so that you don't have surprises. Can you put some light on the retempering of concrete and its advantages and disadvantages? Pritish Sen. Retempering of concrete, you are talking about dosage of water and redosing of admixtures. We have addressed this issue sufficiently in this presentation, and I can quickly give you a recap. The water needs to be carefully administered. You have to be, if you use some particular amount of water to the admixture, for just diluting the admixture, it's okay. If you use 1 liter of water to a 5 cubic meter concrete, just to dilute the admixture, that's fine. But when you actually administer water, you need to be extremely careful, because you will be compromising the strength and the durability. So my take is that if you need to redose, you need to retemper the concrete, just use more of admixture and within its prescribed limits, rather than going for water. Kindly guide, this is Shantanu Pandey, kindly guide on the possibility of using CND waste in concrete. It's a very good question. Uh, CND waste is permitted, aggregates are permitted, both sand and 10 mm and 20 mm aggregates in the latest revision of 383. In structural concrete up to M25, you are allowed to use 20%, 25% of either sand or of aggregates. But then there should be sufficient precaution that has got to be exercised in this situation, because what happens is that you may get CND. If it is from the known source, then you know that this concrete is clean or unclean, or where it has been exposed to. But if you're getting it from multiple sources, your concrete could be exposed to chlorides or acids, or different types of elements, and that is crushed. So you need to ascertain the chloride values in the water demand will go up. We understand that the water absorption of CND waste will be in the range of 6 to 8%. The water demand will be that high. So you need to understand that. So there are agencies. There is a project which Sintef of Norway is doing in India at the moment, on a ministry level agreement between Norway and India. And there they are giving guidelines how to use CND waste in concrete. So I don't have much time left. I'll have to take 1 or 2 maximum questions. Whether it is possible to use recycled water in concrete, I've addressed that. I think you can. Indian standard does not permit this, and there should be understanding, or there should be a change to this for Indian standards for you to use it in India. But there's no reason why you should not be using it. So this is something which needs a change in specification. Can we supply self-compacting concrete in RMC? From Ganpati Mumbare. Of course, self-compacting concrete is a very common product especially in the metros. When you use My1 shuttering, on a monthly basis, around 2 lakh cubic meters every plant is doing in Mumbai. So what I would say is that unfortunately the time is up. I will answer all your questions back, and I have taken the questions, and I will revert back to you on your email provided. Thank you so much for listening.